So we have to ship the x over to the right side and then start or complete the square process. So we have y squared plus y plus blank equals negative x plus blank. The reason why I'm putting in the blanks is so that I remind myself of where the complete the square portions are going to go. Right? Now, through all the times we've been doing completing the square, hopefully by now we realize that there is a nice shortcut. What's half of 1? That drops into your parentheses. Square it, and what goes to both sides? 1/4. Okay. So now we have negative x plus 1/4. It's very close to an x minus h, but what do I have to pull out on that side? Take out the negative 1. So now I have y plus 1/2 equals negative 1 times x minus 1/4, quantity squared. And now I can figure out where my vertex and my focus and all that mumbo jumbo is going to wind up being by doing that. All right? It's like a maze we had there. The biggest mistake people will do when they write out where your vertex is I bet you some of you guys wrote negative 1/2 and 1/4 for your vertex.
Yeah.
It's 1/4 negative 1/2 because the h value goes with x. That's usually what happens to most people when they get this, when they have a y squared parabola. They put them on the wrong sides for the ordered pairs. Okay, so just be careful with that. So your vertex will be located at 1/4 negative 1/2. Y squared, let's see, 1, so here's 1/4, here's 1/2. We'll call it about there. What's our value of p? Well, we have to set we have to take the 4p value and set it equal to negative 1, so our p value is okay. Which means, what direction does this open, left or right? Left, good. It's opening to the left because the p value is negative. Okay, and it's a y squared, so it's going to go left. The p value, remember, is your distance from your center to your focus. So my focus is going to be located at 1/4 to the left, which is at, so here's my vertex. My focus is going to be at 0, negative 1/2. Where's my directrix? Yep, I go 1/4 to the right of the vertex, and it'll be at 1/2 then. Very good. And x equals 1/2. It's 1/4 more than this. And it just goes something like that. Really, the biggest mistake you'll make is when you have the y squared parabola, you'll accidentally flip-flop your ordered pairs. And it happens all the time. That's what happens all the time. So don't let it happen all the time. Fight the urge. Fight the good fight.
Yesterday, the sub had the video so loud.
Oh my
It's
God.
like you were
It was
screaming
so
at
loud.
us. Like, the video was so loud.
You mentioned that earlier. Yeah. So
What?
he would never say that. Well, I'm trying to think.
Well,
What?
it's like
You know what I did? I used the video from your guys' class wait, no, you guys were 12th hour, weren't you?
Yeah,
No,
you
you
used
used-
Christian's class.
Yeah, it was 6-7. I thought you guys were I thought you were 6-7. Darn it, I should
It
have used 12.
was
I was
me and all
12.
the boys.
Yeah, that's right. It would have been 12th hour. You're right, because you were.
Yeah.
Sorry, I totally forgot about that. I
It
thought
was
you were
really
6-7.
loud.
At one point.
Because that would have been funny if you were yelling at them.
It was so loud.
I guess the sub was just trying to make sure you guys
Then
stayed awake.
eventually he like turned it
"Come
down.
on," like,
It
bro,
was like 5 minutes. She was like, is this too loud? I was like,
I like shut the door and I'm sure you probably could hear it in like the photos.
Why is that now?
Yeah.
No.
Day 2 stuff.
Yes.
What do you got?
40.
You were saying 40?
Yeah. 32. And if you can just tell us how to put like 60, 63, so it's in the calculator, and then we can figure it out. I probably just didn't know how to put it in the calculator. Tell us what you're doing.
40.
You're right here, what are you talking about? And I'm like, no, I can't see them right where.
Okay, so this tells you that,
Where?
it'd be easier to show you this way.
Yeah, of course you would.
Vertical axis,
Not quite.
axes. Yes, there's vertical axis to the roof.
Okay.
Axis, you mean axis, and then I was saying access, I mean axes. There's axis. I'm not very smart, I'm very smart. Or- So we gotta figure out, it's on the vertex is on the vertical axis, and it passes through the point, -3, -3. If I'm not mistaken, this was right, the equation, right? Anyway, so you gotta figure out, this would give you, vertex at the origin, okay. So if we have vertex at the origin, and we know that it goes to the point -3, -3,
Wait, how
is
do
this,
you know that?
it said in the instructions.
Oh, okay.
And it said that if it's opening, which way is this opening?
So what do we have? Yeah.
It's got to be opening downward. Okay. Got to be opening downward in order for this to work, because that means it's going to be an x squared or a y squared parabola.
X squared.
It's going to be an x squared parabola
And then negative.
with a negative value of p. That's why it's opening downward.
Wait, why doesn't everyone be negative?
Yes. Yeah. The other side, you're right, because it's symmetrical, so it should be at 3 and 3. Yeah. Okay. So now what we have to do is figure out, excuse me, how we get the rest of it. Bless you. Well, knowing that it's going to be a x squared one, that means it's going to be x minus h quantity squared, so equals 4p y minus k. Well, we know that the p-value's got to be negative, and we know that h and k's are 0. So it's going to be x squared is 4p and then y.
Wait, is P 3?
I don't know yet. I know it's got to be, I know this should be a negative though, because it's opening downward. Okay. So what we have to do is figure out the value of p. Don't I know the x and y values? See what I'm doing? I'm just substituting in. So this is 9 equals 12p.
Negative.
I know I moved it here, but I know it's got to be negative because it's going through that way. So your answer then would be x squared, would it be 16 or 12, 3/4 would be negative 1/3. Why? It's a lot of substitution jumping to get through some of these things. Okay. What was the other one? When you have focus and directors, that's easier because you know you're at the center. You're just counting up and down. Yeah, it tells you right here. And vertex. The The ones that aren't at the origin, I believe, are below that.
Okay,
That's these
I
guys.
don't need you to do that one.
Do you guys want to walk through? We had to do one of those, didn't we? Which one was it? Well, I think it was 47, right? So if I look at 47, you have vertex at 0, 4, and a directrix at y equals 2. Whenever you have this style, you always want to kind of sketch out what it looks like. So if I vertex is at 0, 4, and directrix is at y equals 2. Y equals 2 is a horizontal line through 2, very good. What direction is this opening
Up.
up? Very good. It's got to be opening up because it's always going to open the opposite direction the directrix. So it's got to be opening up. If it's opening up, is it an x squared or a y squared parabola? X squared. It's an x squared parabola, so it's going to be an x minus h quantity squared is 4p y minus k. The distance from your directrix to your vertex is the same distance as it is from directrix to focus. So 2. So your p-value is 2. So you get x squared is 8y minus 4.
Oh.
Does that make sense? And I don't recall if the book actually distributes and solves that. Did they write it as 8x minus 32? I don't remember off the top of my head. How to get repeat? Remember, p-value is the distance from focus to vertex. Opposite of p is vertex to directrix. So if it goes down 2, it's got to go up 2, and that's why we know p-value is positive because it's opening upward.
Could we just do like one of 60? Because I couldn't figure out how to put it in the calculator. It says do it direct.
Which one you said? 60?
60 or 63, 66. They're 66.
So you're starting with this equation. I'm just going to write it out. It'll be easier to show you. 66. You guys want to get, instead of using the graphing calculator, you can probably go through the table and do all that kind of junk
But
look
I
and stuff.
didn't know how to
Wait,
put,
what's
like,
your working problem?
I don't know how to put
66.
stuff on both sides of the
You can't. You have a y equals button for f of x. So solve this equation for y. So here's what you do. Y minus 7,125 is the quantity x minus 6.25 quantity squared divided by 12.5. That's how we move the first thing. And then I add 7.125.
Couldn't you divide by negative 12.5?
Yes. Thank you for paying attention. And that's what you do. A lot of these things you have to do solve for y. You can still put a y squared parabola in your calculator. Do you guys know how to do that?
No.
You push menu. Wait, I got this. Menu, graph, entry, edit.
No, you would just solve for y and take the square root. So you have 1 half and the other half, 1 plus root and 1 minus root.
Well, there's a way. You can push parabola and then you can do this.
Oh, is it in there too? I didn't know if the parabola stuff was on here.
But I didn't know like which ones, so you can get all that.
Oh, cool. At least it gives you the equation. Nice. 135. Still haven't found one. I haven't seen no written on it.
Okay, well, is someone trying to scan?
Yeah.
Have you seen ET? What about?
30 to 40 bucks.
Okay, no,
Saves you a couple bucks.
more than I thought.
A lot. So let's look at the last part of this then. Let's talk about the tangent lines to the parabola. This is more of the calculus stuff that we get into. This last couple of sections, we're going to try and bring in a little bit more of the calculus to it. It's actually pretty simple to work through. It's just a few step process. So what we want to look at is when you graph a parabola, I'll move these things around here. Whenever you graph, guys, come on. Whenever you graph a parabola, your focus point, the distance from your focus point to some point on the parabola is going to be the same distance as it would be if this point came through and touched here. It creates an isosceles triangle. And what we can do is find the slope at any point on that graph by doing this. This is just that last little bit of attention. This is the slope of the table line. This is the calculus part of this unit. So what we look at here is that in a parabola, the tangent line, this tangent point, oops, try not to cover up too much here, is that any point on the parabola is going to have this distance to the focus. Well, this distance from the focus to this point is going to be the same distance to where the parabola, or excuse me, the tangent line would go through the axis of symmetry. So the vertical axis of symmetry for an x squared parabola gives us some value here and here that creates what we call the tangent line. It creates an isosceles triangle.
Wait, so what's that for?
We find it. We're going to find it. It's going to be some point on the vertical axis, or excuse me, the axis of symmetry, if you will. Eventually, what we're going to do is, I think most of the problems that we start out with these things is that our center is going to be at the origin. So what we're going to find is the y-intercept. Okay? We're going to find the y-intercept in relation to some other point on the curve itself, and then write the equation of that line. Calculus is basically a whole lot of slopes of tangent lines. That's a lot of that. And this is one of the methods that we start to show you guys when for some of you guys when you go to Calc next year, you'll see how this works. By the end of calculus, you guys are somewhere in the middle, you will not only be working with slopes of lines like this, but you're going to figure out, and actually do this in stats too. At some point in time, if this is a curve here, you can find the area underneath that curve also. And that's a stats thing. All right? Tangent line? What we're going to do is we're going to find the equation of the line that's tangent to the curve at a specific point. It's a couple of steps. It's actually pretty easy to do. It looks weird, but it's pretty easy. Okay. The integral is the integral. What you guys, the little squiggly S value?
I don't remember. I stopped taking stats.
There you go.
There's more.
So let's look at this. Let's look at the equation. We're going to write the equation of the tangent line to the parabola of y equals x squared at the point 1, 1. And the way that I like to set these things up is I like to start them by drawing it to get a sketch of the idea of what it looks like. It's an x squared parabola, which means what direction is it going? What's up, buddy? Hey, we're doing tangent lines.
Tangent lines? That's exciting.
It is. You're just happy you're done with it.
No. We're watching on your cell.
Yeah. So here's what we do. What direction is this going? Is this going up, down, left, or right? It's
Trends. I can't. The dust is too little.
It's so much worse with the water bottle in your hand.
I would have laughed so hard.
It's not my fault. The dust is too little to my legs. Excuses. I'll be shorter. I'm sorry.
It looks like this. Everybody okay with that?
Yep.
X squared parabola, centered at the origin, and it does that.
Do all of them have to be centered at the origin?
Not necessarily, but it's all the same process.
Wait, so what is the y? Listen.
What we know is that somewhere in this curve, somewhere in this graph, there's a focus. And what we need to do is find where that focus is. So, y equals x squared, what's the term that I have to set for p equal to solve for p? What do I set for p equal to find focus? 1.
But why 1?
What's the coefficient? Remember, the coefficient in front of the x squared is is how you develop where the 4p is. Okay.
Wait, I'm still confused on what that is. Is that the line?
What?
The line.
Remember, that's the generic form. Since it's at the origin, the equation of the parabola is y equals 4px squared.
I thought it was y squared equals 4.
There's. No. Did I type that in backwards? I did, didn't I? I'm sorry, I didn't even realize I did that. Anyway, so what we're doing here is
Which one are we using?
we're using
X squared equals
4py.
Or for you.
I'm failing miserably. All I know is that my p-value is 1/4.
Right, is this squared equals 4p?
So I know that our value there is going to be a 4th. The focus is up here at the ordered pair of 0 and 1/4. Everybody okay with that?
Sure.
Here's what we do. What we need to do is find this distance. The distance formula. So I need to find the distance between 1 and 1.25 and 1/1. You all right, Cole?
No. Oh, it's Luke. He's walked back and forth like 10 times. He has a different look on his face every time. Now he's not gonna walk by.
Are you sure you're not seeing people?
No.
It's kind of hard to
I see dead
not
people.
see.
Anyway.
There it goes.
Anyway, what we're trying to do is we're going to write the equation of this line, but we need to find this distance. So distance formula. Change in x, change in y. What's 1 minus 0?
1 minus 0.
What's 1 squared?
1 squared is 1.
What's 1 minus 1/4?
3/4.
What's 3/4 squared?
No, 1/9/16. So
Okay.
30.
So then we have
No.
16/16 minus 9/16 is 7/16, right?
Yes.
So this distance is the square root of 7/16. Sorry about the really crummy decimal there. Which means, to find the point down here, it would just take the focus point and add the square root of 7/16. And that gets me the other intercept. Actually, I'm not adding, excuse me. I'm moving downward, so I have to subtract. Okay.
So do negatives. Oh, wait.
I take, because I'm,
the distance from the Yes, I need to know the
and that's how you find that other ordered pair. It's a little nasty sometimes, but that's how that works.
So you add to the y, or we subtract it.
Because you're moving it downward. If we were going a different way, we'll go the other way here. Let me grab my another example here. I had another one. I think I have a cleaner one. This is 2, right? It's pretty. Yeah. Then you go from there to write the equation then with the ordered pairs. What's the one I had? Let's look at this. Let me do another one. The other one I have is a little bit cleaner. So let's say we have y. X squared is 2y. And then we have ordered pair of 4 and 8. This one should be cleaner. Yeah, because we moved down. Remember, you're going to have to adjust for whichever way you're going. You might have to add to it or subtract to it. So let's try a different one. It should be cleaner. Same deal. An x squared parabola. I know it's opening upward because it's possible. So from here, I know that the ordered pair is what, 4, 8? Be all right with that? I have to set it's at the origin. I think they tell you if they're going to be at the origin here. I don't think we get too crazy. Yeah, these are all at the origin because there's no H and K. All right. So what we have now is we have our 4p equals 2. We're right back. Which means, what's the p value? All right. We're all right with that then? So we know that it's doing this. And what we want to do is figure out the equation of the line through that point. All right? Which means we got to find the other point down here. So if my focus is at 0 and a half, I can find that distance. Yeah, you find that distance, and then you drop that distance below it, and that gives you your other ordered pair, and then you can find the slope between those two. The other one, the numbers are so bad, so I wanted to go try and do something a little cleaner. Okay. So we go, let's see, distance formula. Point was 4, 8. We get that. So we know that our p value, excuse me, our focus is at a half because our p value is a half. So we can draw this. That was that distance from the center to the p value. That was at just show you this a little bit better. So this was at 0.5. All right, that's where our focus point was at. What we want to know is the distance then to the point on the other one, where it was up here, from here to here. Because that distance is going to be the same. Can't draw this at all, can I? Would be this. Man, this looks awful. These distances would be the same. Okay. So we. That would be awful.
That would be really awful. So you never know. Sometimes you don't.
Yeah, that's true.
That would be like really ridiculous. I'll probably just
I'll probably think of a problem like this.
find the variant and then make the parabola.
Wow.
You got you good.
Okay, so you might have to put it in his head.
No, we couldn't.
No.
Why not?
There isn't. It's direct from impossible.
What about if you made a problem?
No, that would be just goofy. So, what we're doing here is that we know that once we find this distance should be the same. Okay? What we have to do though is we're coming from here to here. We're trying to find that ordered pair. This is going to get us some x-intercept. Okay. Now, remember when you're doing that, it's going to be the distance from the focus downward, not from the origin downward. Okay. That's what people might mess up. So we look at change in x was what? Square root. It's 4 minus 0. Quantity squared. 8.5. So the distance here was 8.5, which means the distance down here from here to here would be 8.5, which means this value here is how much? 0.8. Very good. Does that make sense? That's how you're able to decipher where that ordered pair is. So now, if I want to figure out the slope of that line, I'm going from 0.8. Was it 0.8 or 0 negative 8?
0 negative.
Yeah, it should be negative 8. Oh, come on. Because it's below that. So 0 negative 8. And then the other ordered pair was what? 4 and 8? Remember how to find slopes?
Change in
Change in y or change in x. So this would be 4 minus 0 over 8 minus negative 8. Slope of 1/4.
It's gonna ask us to find the slope.
I'm going to write the equation of the line.
y.
Where? Oh, you're right there. I found you. All right. We're okay. Distance formula to get this, right? Which means this distance is the same. If this is total distance is 8.5, and this part is already 0.5, that meant that this ordered pair where this stops has to be at 0 and negative 8 because we moved down.
So wait, that distance is the same. How do you know?
These two distances are going to be the same. Okay. So we just take out the half. We're left with 8 moving downward. That's why it's at negative 8.
Are you trying to find?
Is that? I'm not talking between these 2 points. No, I'm trying to write the equation. Because what I'm doing is I'm writing the equation of the tangent line. So we have our slope at 1/4 and ordered pair at -8, which means y equals 1/4 x minus 8. That's the equation of the line that is tangent here. Okay. The slope of the tangent line is 1/4. Y equals 1/4 x minus 8 is the equation. Now, one of the things that you'll start to see here is that as we get into the more of the calculus stuff, kind of what we're doing here is taking what's called a derivative.
Oh.
And we get to that later. We'll start talking about, and that's when we start looking at limits next week. And this problem comes back around, and there are quicker ways of doing things, but this is the basics of all of it. Okay. What I wanted you guys to try and do today, just to add to this 10 tubes, actually to get to the ellipses, try 56, 57, and 58. I want you guys to do those three. It's just write the equation in line. It's the 741. So it's still 741. Yeah. And this should be, we should be done with 10.2 after these. We'll look at one of these tomorrow, then we'll jump through the ellipses. Remember, when you're doing this, you're finding the focus to the point. We're centered at the origin. You're trying to write the equation of that line. You get the distance here. This distance is the same. The only trick is that this distance 2 is going to be, you have to take out whatever your focus value was. And that gives you the ordered pair. That ordered pair is going to be from the distance, subtract out your focus, and that gives you your leftover from the origin. And go from there.
Let's go, boy.
Surprise! Big guy! Yay! Yeah, I gotta go back to
Professor
Professor
Murphy would make his return.
I should get a suit jacket and patches.
Yes, suede elbow patches. Lead jacket, suede elbow patches.
No. Pretty too warm wearing sleeves and wearing a jacket all day.
Mr. Murphy, the
Yes.
homework I put on your desk was from the